Hello there, I hope your day is going well. Today I'm going to help you review the lesson you learned last night, which is 4.1 on Extreme Value Theorem. By the way, this Thursday you will have an opportunity to retake the exam, but in order to retake the exam, you must do your test corrections and figure out what you did wrong. I will be here tomorrow, Wednesday and Thursday from 7:30 and throughout tutorial to help answer any questions that you may have. So definitely stop by and see me, and we're going to work together to make sure you're going to do really well on the retake. That's Liam, that's my newborn, and that's Allison. Here's 4.1, Extreme Value Theorem.
Extreme Value Theorem. Every function on a closed interval AB must attain an absolute max and an absolute min. Before we can find the absolute max and absolute min, the first thing we do is we go ahead and identify all the local max and all the local mins. So here's a function. I'm going to start by identifying all the local max. Notice that I have identified a first local max. I'm going to do that. We're going to find a second local max, which happens to be right here, and a third local max, which happens to be right there. The next thing we do is we find all the minimum. That's the first local minimum, followed by another local minimum, and followed by a third local minimum. Now we're going to check all the three local max, and the highest one is called the absolute max. So this, after looking at all three local max, this is our absolute max. Similarly, we're going to look at all the three local mins, or how many ever there are, and this happens to be the lowest one, so we call this the absolute min. So an absolute min is also a local min. An absolute max is also a local max. However, the other way around is not true. Just because a point is a local max does not mean it is an absolute max.
Another thing that I want you to know in this refresher is how to find the critical values and what is the critical value.
Critical values of a function is all the values, all the x values, where the derivative of the function equals to 0. So let's take a look and find all the critical values for problem A. Looking at the graph for problem A, notice that when x equals to -4, that's where the derivative equals to 0. So that x equals to -4 is a critical value. Also, at x equals to -1, that's where the derivative equals to 0. So that's also a critical value. And last, as we continue to analyze the graph, we see that another critical value is where x equals to 3. So let's write all that down. The critical values for problem A is going to be at x equals to -4, -1, and 3. Those are the critical values. Now, these values are very important, especially when you're trying to find the maximum or the minimum. So being able to find those values are very important. Let's take a look at an example where you're not given a function. You're not given a graph. Let's say that you are given a function, which looks like that. f of x equals to 2x to the third minus 15x squared plus 24x plus 7. What are the critical values of this function? In order to find those numbers, the first thing we do is we have to analyze its derivative. So we go ahead and use the power rule to find the derivative of that function, which, as you can see, it is 6x squared minus 30x plus 24. Because critical values are where the derivative equal to 0, what we're going to do is we're just going to set f prime equals to 0. So notice that I replaced that with 0, and now I have to find the x values where it will make this equal to 0. In order to do that, we've used the factoring method However, before we start factoring, notice that all terms are divisible by 6, or they have a 6 in common. So if we divide both sides by 6, we can really trim down this trinomial. So I divide both sides by 6, and now I'm looking at a very easy trinomial to factor. And that's what I'm going to do next. I am going to factor the right side of the trinomial, which gives me x minus 4 and x minus 1. As you can see, what x values makes the derivative equal to 0? Well, you probably guessed it right. When x equals to 4, that's where this equals to 0, which equals to the derivative, and also at x equals to 1. So finding the critical values, especially when you have a function, requires that you find the derivative first and then factor it and then locate the x values that makes the derivative equals to 0.
Alright, well, I do have to step out to buy some milk for Liam, so I'm going to let Alfred show you how to find the absolute max and absolute min of a function.
Let's find the absolute max and absolute min value of this function on a closed interval. The first thing we do is we need to find all the critical values and endpoints. In the previous segment of this video, we found the critical value of this function, and also the endpoints are given to us. So let's identify those values. These values are where the local maxes and mins are going to take place. From these local maxes and mins, we are going to find the absolute max and absolute min. To do so, the next step after finding the critical values and points are to plug each value into the function. So I take each number in step 1, plug that into the function, and its values are what I'm analyzing. So as you can see, these are the values that came from the critical points. We can now determine that the absolute max value is clearly 43, and also the absolute min value is -9. Now you might be asked to find where does the maximum value take place. Your response to that would be the maximum value took place when x equals to 6. Similarly, you may be asked to find where does the minimum value take place or occur. And again, your response to that would be the minimum value occur when x equals to 4.